Okay, so this is the Murray Amateur Radio Club. This is our beginners topics class. And tonight we're taking on the next installment in our Getting Started with Amateur Radio series. We're going to be talking about equipment. Um, so without further ado, I'll just jump right in. So if I take my click, come on, computer, what are we doing? Back. Okay. All right. There we go. We're good. All right. So you've got your license. What now? You're going to need some equipment. You need to know how to set it up, configure it. You need to know how to operate it, and you know how the different parts of it work and things like that. And you need to actually use it. Doesn't do you much good if you buy a radio, get it programmed and set up, and then sit it on the shelf for a year. That's not a great way to get into the hobby. So you do have to actually use it. So what do I need in my shack? This is a picture of Dan's shack. No, actually, it's pretty close. Um, but what is a shack? So a shack is where you operate your radios. So for some people, they're going to have a dedicated room in their house or in a shed out back or something, wherever their wife lets them have it, and they will have their radio set up in there. For me, my shack is usually my car because I'm doing most of my operating from the car. And if you've got a handheld, your shack is wherever you happen to be. You have your radio in your hand and you can use it at any time. But if we take a look at this guy's shack, you can see he's got some stuff going on here. We're going to talk about some of these different options and some of the things that you see here. Um, but uh, but yeah, this you might consider this a little bit of an extreme example, but you can see there's a lot of different things that you might want to have in your shack. So let's talk about what kind of equipment we would want or would like to have for our amateur radio shack. Well, the first thing you're going to need, pretty obviously, is a radio, right? It's hard to do radio without having a radio. So you're going to need a radio. You might want more than one radio. Talk some about that. Um, the typical options are you might have a VHF, UHF radio. You might have a single band or a multi band. It might be a handheld. It might be a mobile. It might be a base radio. Um, you might also want to have an HF or multi-band radio, and that may be a portable radio or a base radio. So there are HF radios that are made to go in the car, and they're designed to be operated in the vehicle. There are also HF radios that are designed to be hand carried, like in a backpack, and used wherever you happen to be. Um, but in general, when we talk about having a radio on your person, we're going to be talking about a handheld radio that's a VHF or UHF radio, or a multi-band radio with both. So there's a few different types of radios. Let's talk about some of these radio types. The first is the ubiquitous HT. HT stands for handy talkie, and you'll hear people talk about, oh, I have my HT, it's a such and so, right? Handy talkie, it's not called a walkie talkie. So back in the World War II days, when they first had man portable radios, the walkie talkie was a pack that weighed about 75 pounds that you would wear on your back. And it was called that because you could walk and talk with that radio. Um, the modern military radios are much smaller and lighter, but there are still some that are carried in a pack that uh, have batteries in there and things so that they can operate and walk around with them. But what we talk about when we talk about a handheld radio is we call it a handy talkie because you hold it in your hand, right? So it's a handy talkie. It's handheld, it's battery powered. The radio, the speaker, the mic, the antenna, the battery, they're all in one unit. Um, how many people brought a handy talkie with them tonight? Two people did. So if you want to hold those up and show people just what a handy talkie looks like. So there's a few different examples of a handy talkie radio. And you can see it's got an antenna on it. It's got a little unit that has the battery and the radio and everything in there. There's a mic and a speaker on the front. There's usually some buttons. There's a display. Those are all parts of the radio. Generally, those will be single band. They'll either be VHF or UHF, or they'll be dual band with both VHF and UHF, typically 2 meter and 70 centimeter. Or you might find tri-band radios, which typically will be 2 meter, 70 centimeter, and the 1.25 meter band. But you may find a tri-band radio that has 6 meters. You may find one that has, one of the gigahertz bands or something like that. So those are other options that you might find out there. Prices for these range from $27 for a Baofeng up to several $100s. So let's look at a few different examples of handy talkies. So the first is the infamous Baofeng radio. These things are cheap. I've seen them as cheap as $19 on Amazon. I like to call the Baofeng the goldfish of amateur radio, because if it breaks, you just flush it down the toilet and get a new one, and they're not that expensive. But with that cheapness comes cheapness, right? So we'll talk about that. There are several different brands or models of these. They all look pretty much the same. You might find one that's labeled B-Tech or Baofeng or Radio Oddity. There's a few different brandings that you'll see on these. You might see one that's labeled Wouxun, or there's a few other brands that are out there as well that are basically the same radio, right? Don't believe all the advertising that you see. I've seen advertising for these that say that they can put out 10 watts. And then when you go and you actually measure it, they put out 4.5 or something like that. Sometimes you'll see packaging that says, buy this great radio, you can use it on GMRS. Well, yes, you can, but not legally. So that's something to consider as well. Sometimes these radios also are not the greatest hardware wise. They will have things that we call spurious transmissions, or what's the word I'm looking for, you guys, where it's on a harmonic frequency. So when you key up on a particular frequency, the radio will also transmit a stronger signal than background on some frequencies that are harmonic with that frequency. Now, the FCC has rules that say you're not allowed to have more than a certain amount of power on those harmonics. Some of these Baofeng radios don't follow those rules, and they'll put out energy on frequencies that you don't want them to. So that's something to think about. Dan, you have a comment?
That's pretty bad. British transmission going into the public service payments. So, great radio to start out with. There's your learning playground, right? And it's cheap. But once you get into it, it's best to get a little bit better. One of the reasons why it's lousy radio, and any radio like that, is it's called radio on a chip. The entire radio is on a chip. It's worse than SDR. So there is no, finals are horrible. The front end is horrible. It's a pseudo radio, but a great radio to start out with.
Dan points out that in an emergency type of situation where you're interoperating with a public served agency, those agencies often will disallow the use of Baofeng radios, specifically because they are noisy, and sometimes those spurious transmissions can get into the public service radio frequencies and cause interference and problems with that. So that is something to consider. Also, he mentioned that these radios are great to start with. So if you are just getting started and you want a radio and you don't want to spend a lot of money, it doesn't hurt to buy one of these and use it to learn more about the hobby, get out there and start operating. But as you advance in the use of the radio, you will find that you want to spend a little bit more money on a different radio. We're going to talk about some other options in a sec, but other things that I've seen with these is, as Dan mentioned, they have it's basically a radio on a chip. So it's it's a software defined inside a chip. So there's a small computer in there that's making the radio signals. And then there's an amplifier to put those out on the antenna, but it doesn't have very good filters. It doesn't have any kind of stability controls or anything like that. There's no real frequency tracking or monitoring. It just basically it says, well, I'm going to make this signal and I'm going to throw it out there and see what happens. And so that's something to consider, is that yes, it's a cheap radio, but being a cheap radio, it's a cheap radio, right? So doesn't hurt to have one in your toolkit. These things are pretty much indestructible. I mean, I've got one that's been dropped probably 4 or 5 times on cement, and it still operates just fine. So I haven't given it a bath yet, but I know people that have had these things go in the water, and you pull them out, shake them off, and they still work. So it's not a bad radio to have in your kit, but as you get more advanced, you're going to want something different. So speaking of something different, here's an example radio that we as a club recommend. This is the TYT TH350. This is a tri-band radio. It operates on 2 meters, 70 centimeters, and the 1.25 meter band. These are not super expensive. You're available around $72, I think, last time I looked. If you look around, you can get one of these that comes with a tri-band antenna as well, which is really nice, because then you're not changing antennas. We'll talk more about antennas in a little while. But for a cheap radio, it's actually pretty good. The signal's pretty clean. The speaker and mic are fairly decent. You can hear, and they can hear you pretty well. And it's pretty easy to use and program. So this is a decent radio for not a lot of money. It's a little more expensive than the Baofeng, but you get what you pay for. Speaking of getting what you pay for, this is a Yaesu VX6R. This is from one of the big three radio manufacturers, the big three Japanese radio manufacturers, which are Yaesu, ICOM, and Kenwood. This is a high quality radio. These things are relatively inexpensive. I've seen them at Gigaparts for about $250. They used to be what, 400-ish? Yeah, so this is also a tri-band radio, sort of. It'll do 5 watts on 2 meters and 70 centimeters, but it can only do 1.5 watts on the 1.25 meter band. Now, around here in the valley, 1.5 watts is probably plenty to hit our club repeater. We've had people check in to the club repeater with these radios, and you can hear them just fine. So don't consider that, well, it doesn't have a full 5 watts on 1.25 as being a showstopper for you. If you want to get a decent radio, this is a good radio. And it's not crazy expensive. It's quite high quality. It's very well built. These things are pretty robust as well. I think they're IP67 rated or something like that. Yeah, they're waterproof. They're Dan uses one of these radios when he goes out on deployments. So that's a vote of confidence right there. Now we've got one more HT to look at, and that's the Kenwood THD75, which is not yet available. But when it comes out, this has been announced by Kenwood. And I love Kenwood's radios. They're really easy to program. They're really easy to use. They're great radios, very capable. They are not cheap. This is replacing the D74, which there was some problem with obtaining some particular chips that go into the radio. And so Kenwood stopped making the D74. They've announced this radio It's not available yet. I expect it will probably be around 450 to 500 bucks when it comes out. This radio has all the bells and whistles, right? It's got a color display. It's a full tri-band radio. It's going to have 5 watts on all 3 bands. It includes D-Star support. If you're interested in digital, it includes APRS support. It has a built-in TNC that you can access from outside the radio. So you'll find that some radios will say, well, it has APRS support, but only using the built-in functionality of the radio. We've got other things coming where we'll talk what APRS is, but it's a packet radio technology that allows you to share your position information and find out tactical information about what's going on around you over the radio. And the TNC is a terminal node controller that allows you to connect a computer up to the radio and use it to communicate digitally. So some of those radios that say they have APRS support, they don't expose the access to the TNC outside the radio, but the Kenwoods do. So that's, if you're interested in digital modes, this is a good way to get started with something like that. This radio is going to be like the Cadillac of handhelds when it comes out. And like I say, it's got all the bells and whistles, and it's a super high quality radio. Now, do I want to take a $500 radio with me when I'm crawling around in the mud somewhere or inside a broken down building or something? I don't think I want to take my $500 HT when I do that. So I might want to have a couple of different radios for a couple of different purposes. So that's something to consider. All right, let's talk about mobile radios. So we're going to kind of lump these together, mobile and base radios, because really they're the same thing. The difference is if it's installed in your car or your truck, then it's a mobile radio. If it's installed in your house, then it's a base radio, right? And we're talking specifically about VHF and UHF radios for this. These are typically higher power than a handheld. They typically run off of a 12-volt power supply, so either off of a battery or off of a desktop power supply. There's a separate microphone from the radio. It's not something that you're going to hold up to your head. They might have an external speaker port. They might have a speaker on the radio itself. There will be definitely an external antenna. It does not have an antenna built into the radio. You have to connect an external antenna to it. Excuse me. Some of these will have a data port for easy connection to a computer. That's a feature that is very nice. A lot of the newer, cheaper ones of these you'll find don't have that. And so if that's something that you're really interested in, you're going to want to look around for a radio that has that feature. Dual band units are fairly common. Tri-band units are less common. And there are even quad band radios of this type out there. Prices for these range from a couple $100 to several $100s, where several is like $600 or $700. So that's something to consider as well. It's how much you want to spend on the radio. So let's look at a couple of different examples of mobile radios. So one of the ones that we recommend in Mark, or that several of us in Mark have, is the Anytone AT5888 UV3. Availability of these has been limited in the past. I know they're available right now. If you go out and search for this, note, if you want to get the tri-band version, you want to make sure it has the 3 on the end of it, UV3. The UV2 is only a dual band. So if you don't care about the 1 1/4 meter band, look at that one. I've seen these typically on sale for around $250. This will do up to 50 watts on the 2 meter band, 40 watts on the 70 centimeter band, and 25 watts on the 1 1/4 meter band. 25 watts is a lot of power on 1 1/4 meters. Dan, which radio were you using when you were using the 5888? So at our last net, Dan was out by Tooele, which is 40 miles west of Salt Lake, with a mountain in between, him and the repeater, and he was able to hit the repeater just fine from there with this radio on 1.25 meters. So 25 watts is no slouch on 1.25 meters. This radio has good features. It's a very capable radio. It's pretty robust. I've got one in my truck. A lot of people in the club have them, and it's all around a good radio for a tri-band. Here's another one. Oh, yes. Let me make a comment about that. One feature that you might look for in mobile radios is what they call a detachable head. So if you look at this radio, it's going to be a box about 6 inches deep, 2 inches high, and 5 or so inches wide. And that may be inconvenient to put somewhere in your car where you can access it or get at it. But what this radio has is called a detachable head, which means the front plate, the face plate that has the controls and the display, can be separated from the main body of the radio. So you can run a cable, you can put the radio like under the back seat of your car or whatever, and run a cable from that up to the front of your car where you plug it into the head. And then with this particular radio, the microphone actually plugs into the head, which some radios do that. Some radios you have to run a separate cable for the mic all the way back to wherever the radio is. One of the things I love about this Anytone radio is that the mic plugs directly into the head, so you don't have to worry about running multiple cables. Dan. Dan says he has one of these on his motorcycle as well, and it's very convenient because you can put the head where it's convenient to access. He's got that up on the front, in front of the controls on the bike, and then the radio itself is in the back, and there's only one cable that runs from the head back to where the radio is. So that is definitely something to consider, and not all mobile radios are going to have that feature. So that's not, if that's important to you, that's something to look for when you're looking at different radios. All right. So this one is the Alinco DR MD520T. These ones come in about $450. This is a tri-band radio. It'll do 55 watts on 2 meters. It'll do 40 watts on 70 centimeters, and it'll do 5 watts on 1.25 meters. Again, with 1.25 meters, 5 watts is no slouch, right? You can actually get pretty far with 5 watts on that band. This is also a DMR capable radio. DMR is digital mobile radio. It's a digital standard for audio communications. This radio works on those digital frequencies. It also works on analog frequencies. These types of radios, the DMR radios, are programmed with a code plug, which is a single file that contains a lot of information about programming the radio. And I'm not going to go into that today, but next month we will have a class on programming your radio, and we'll talk about that a little bit. Jeff, I think you've got one of these, don't you? Is it yours is different? Okay. I know there's also the Anytone, which is a 578. 578 is another DMR radio like this that also has that DMR functionality as well as analog frequencies. The 578 is one that does not have a removable head. So you've got to find somewhere in your vehicle where you can fit that whole radio, which it may be easy depending on what vehicle you have. It may not be so easy. Let's see. The next one that I have here is the Yaesu FTM 300DR. These ones come in around $400. This is a dual band radio. It'll do 50 watts on both 2 meters and 70 centimeters. And it also supports digital, but it uses a system called Yaesu System Fusion for digital. And it supports analog as well. This does have a separate head, and you can see kind of in this picture how the head is separate from the body of the radio. So that kind of gives you an idea of what we're talking about when we say, you know, the body, the main part of the radio can go somewhere in your vehicle, while just the display and controls are put somewhere more convenient. Um, this radio also has APRS support. Remember, we talked a little bit about APRS with that Kenwood THD 75. The Yaesu does not give you full access to the TNC though. So where the Kenwoods do, the Yaesu does not. But it does do the APRS stuff. So you can operate it in that way. Okay. So let's talk about HF radio. Well, before we go on to HF radios, I just want to confirm again, these, I call these mobile radios. You can also use all of these radios as a base radio in your shack or in your house somewhere. All you have to have is some way of providing them with 12-volt power. So you'd have a power supply that gives you that power, or you could have a battery or something like that, maybe solar power that's running this radio. So even though I talk about putting these in your vehicle, consider that these also work as a base station at home. They don't have to be installed in a vehicle. Or you could put it in a Go kit of some kind. I don't think I mentioned Go kits in here anymore. We'll talk about Go kits later in the thing. But okay, so HF radios. All right. There are so many options for HF radios that I don't even know where to start, right? Because if you think about HF is really what amateur radio is about. HF is used to communicate long distances. Your VHF and UHF radios, those are great for line of sight, but they're not great for thousands of miles of conversation, right? Your HF radios are. However, you need to have the appropriate privileges to operate on HF. So you probably want to upgrade your license from technician to at least general class if you're going to be getting into HF. Now, these radios will operate on multiple bands typically. There are several different HF bands that go from 10 meters all the way down to 160 meters. There's even what's the 200, 2200 meters. So like the wavelength is over 2 kilometers long, right? So well, maybe a quarter wave, but yeah. So, I mean, you think about the variability that's in HF. There are, you know, a bunch of different bands that you can operate on. There are also different modes that you can use. Typical ones you'll see are FM, which we always use on VHF and UHF. There's also AM or amplitude modulation and upper and lower single sideband, which basically takes away a portion of the AM signal and allows you to concentrate that power on a single side of that transmission. These radios are very capable. They typically have some kind of computer integration or computer control. They call it typically CAT, computer aided or activated transceiver or something like that. I can't remember what it stands for, but basically you can plug your computer into the radio and use your computer to change the frequencies or change the bands or change settings on the radio dynamically while you're operating. A lot of them will have additional features like a band scope or an antenna tuner built into the radio. Going into a lot of detail on those pieces of functionality is outside the scope of this meeting, but we will talk about it in a later meeting, talk more about HF. Yeah, there's so much variability in these. I've got a couple of examples of HF radios that I want to show, and so we'll go into that. But the first one I want to talk about is the ICOM IC7300. This is a beautiful radio. This has all of the features that you want. It'll do 160 meters all the way up to 10 meters. It includes 6 meter support as well, which is one of the VHF bands. It can do all modes, so it'll do single sideband, it'll do AM and FM, it'll do CW, You can connect it up to your computer. It has computer control capability, and it has a sound card built into the radio. So when you plug it into your computer, the computer can say, oh, I see that device as a sound card, and all of your digital operating software can use that directly. So you don't need another piece of equipment in between the two. It has a built-in antenna tuner. So if your antenna is not perfectly suited for a particular band, the antenna tuner will kick in and it will adjust the SWR accordingly so that you're actually getting good power out. Even you won't get that power out, but it won't be bouncing back into the radio and damaging it, right? These things retail for around $1,100. Now, that is a fairly common price for an HF radio, particularly one with all these bells and whistles. You'll see on the screen here, it's got, if let me pull up the laser pointer thingy here. So right here is the frequency that you're tuned to. And then this section here is a band scope. So you can actually see I'm tuned here at this particular frequency, but I can see what's going on a little bit below and a little bit above where I'm at. And I can see visually, maybe as I'm tuning around, I'll see a conversation happening somewhere on here that I can't hear until I tune over there. This band scope is just an amazing feature that lets you tune into conversations that you wouldn't otherwise know were even there. There's so much capability in a radio like this. These things have 100 watts out the door, just out the radio itself, and you can add an external amplifier to take it all the way up to the legal limit of 1,500 watts. So great radio if you want to get involved in HF and you've got the money for it. All right. So what else do I need besides radio? Well, we did a class a while back on computers in the ham shack, and you may want to use a computer if you want to do anything with digital modes, or if you want to do something with WinLink, which is like email over the radio, or if you want to use logging software to log your conversations, or if you want to do any general research about amateur radio or something that you hear about while you're on the radio. So having a computer in the shack is a good idea. If you want to go back and watch that presentation from last October, we talked about a lot of different things that you can do with a computer in the ham shack. So that's something that you might want to have in addition to your radio. Other things that you might want is a power supply. You're going to need a power supply of some kind to operate your radio. Now, if you're in a vehicle and you're using a mobile radio in a vehicle, the vehicle already has 12-volt power available. So you can just tap into the battery on the vehicle and use that. However, if you're operating from home, you're going to need some kind of a power supply that will produce that 12-volt power. Now, when I say 12 volt, I really mean 13.8 volts, because in your car, the alternator is going to be producing 13.8 volts. And so that's the nominal voltage of the 12-volt system is actually 13.8 volts. So, Dan. Right. Dan comments that all the specs that when you're looking at the specs of the radio, they're all based on a 13.8 volt input. Now, typically, radios will say 13.8 volts plus or minus 10% or something like that, which means, it doesn't have to be right at 13.8 volts. But if you've got a separate power supply like this that plugs into an AC circuit and gives you this DC power to operate your devices, then you're going to have nice, clean, solid 13.8 volt power coming out. Make sure you get a power supply that has enough wattage to run everything you want to run at the same time off of that. So, if you've got a radio that wants, 30 amps of power, make sure that your power supply can put out 30 amps at the 13.8 volts, right? So that's something to think about. If you want to run more than one radio, add up how much power they all want to use. Admittedly, they're not going to be using it all the time because they'll use more power when they're transmitting than they will when they're receiving. But what you want to make sure you have enough capacity for is the maximum that you would end up. You might want to have some tools available in your shack, things like cable termination tools or a soldering station. If you want to do anything with, making cables or adjusting the length of the cable to be what you want it to be, having the appropriate termination tools is very important for that. And a soldering station gives you a consistent temperature soldering iron that you can use. A lot of people have one of those little soldering pencils that you can buy for $12 at Walmart. Those things are fine for, oh, I just need to solder this one thing real quick. And, I'm not doing a lot of soldering over a period of time, because they will typically heat up to a fairly high temperature, probably higher than you want, and then they won't maintain that temperature. So every time you use it, it'll drop, it'll fluctuate a lot. A controlled soldering station will give you a lot better soldering ability. And then you may want some kind of test equipment like a power meter or a signal analyzer or something like that, so that you can tell, oh, I'm actually putting out 7 watts on this radio, or I'm actually putting out only 3.5 watts on this radio when it should be doing 5. So what's going on with it? Or you can look at the signal and say, oh darn, my Baofeng's spurious signal is really killing the 70 centimeter band right now, and I probably should stop transmitting, or something like that. Now, you can borrow a lot of tools and test equipment from other hams. So you don't need to go out and invest in a lot of tools and equipment right now. As a beginner amateur radio operator, knowing that these tools are out there and that they're available and learning how they work is important, but you don't necessarily have to have your own. There are experienced hams in the club that have this kind of equipment, know how it works, can teach you how it works and show you how it works, and are happy to come and help you debug your setup or look at your configuration or build a cable that you need or whatever. So when I talk about these are things that you might want or need, keep that in mind, that you don't necessarily have to have this stuff just to get started with the hobby. The other people have this kind of gear and they're generally happy to help you. So what else do you need? You need an antenna of some type. Now, if you're just using a handy talkie, you've already got an antenna, right? There's an antenna on the radio itself. But if you're using a mobile or a base setup, you're going to need some kind of an external antenna. And we could do, there are so many different kinds of antennas out there. We could do a whole presentation on antennas. And antennas are critical to radio operations, because if you think about it, the antenna is responsible for taking the energy from your radio and putting it out into the atmosphere, right? So if you can't do that effectively, your signal's not going to get where you want it to get. Different antennas have different properties. Some of the antennas are what they call high gain antenna, where you'll actually gain power just by using that antenna, because what it's doing is it's focusing the power that's coming into it in a particular direction. These directional antennas will send your signal in a particular direction, so you need to have some way to adjust where that goes to, right? We'll talk about that in a minute. But some antennas will operate on multiple bands just fine. Some antennas will be very band specific. They'll be like tuned for a particular band. And so if you want to operate on a different band, you might need to switch to a different antenna. It is possible to add things like chokes and load coils and other features like that to different antennas to make them work on a different band. If you have the space and you have the ability to set up multiple antennas, sometimes that's a better option. A lot of times people will have a primary antenna that they use for most of what they're doing, and they may have another antenna that they use for other purposes. These two example antennas that you see here, the top one is a beam antenna, and what it's it's a very directional antenna, and it's set, looks like this one is probably maybe might be an 80-meter antenna. So it might work well on 80, 40, and 20. The one on the bottom, help me out, guys. Is that a hex beam? That's a hex beam. So that's going to be a multi-band antenna. It's designed to work with multiple bands, and it's omnidirectional, so it doesn't care what direction the signal goes.
What is it?
Oh, does it? Is the hex beam directional? Really? I did not know that. Ah, I was not aware of that. I'm sorry for steering people wrong on that. The hex beam is a directional antenna, and apparently it is very directional. So that is something to think about. Yes. So if you look at this, there's going to be a driven element, which is probably that middle one. There's going to be a reflecting element, which is the long one that's going to be behind the signal. And then there's going to be a director element that's in front that is helping to focus that signal. So if you're looking at this particular one, it's pointing, I'm going to say down and left. So the signal, the majority of the signal is going to go down and left from this picture, right? So if you're looking at that, yeah, it doesn't come off of the ends of the wires. It's focused by the wires and goes perpendicular to that. So, yeah.
Hey, and then how we get hung up in the house. And mostly everybody said everyone fine, you know.
So Bob says that when we first started the club, he was using what he calls a coat hanger antenna, which I remember when we made those, and it's basically a length of wire about, well, it's a specific length for the 2-meter band, and then it was, yeah, about 19 inches long, and it was soldered onto a connector, an SO239 connector, and then there were 2 legs that came off of that on a 45-degree angle. And Bob hung that antenna in his attic and operated on that for years and got absolutely fabulous signal reports out of that thing. So, you know, when I look at like this beam antenna that probably costs, you know, $800 to $1,000 or more, and then I think about what we did with a couple of pieces of wire and an SO239 connector and some solder, you know, it's what you can get out of an antenna may not be what you think, right? So if you design the antenna accordingly, and there are tons of antenna designs out there for antennas you can build that, you know, one of the antennas that people build for fox hunting is a super directional Yagi antenna. It's made with typically some plastic tubing like PVC pipe and chunks cut off of a tape measure that are a specific length and put on the thing in a specific place. But when you hook that together, you get a super directional, very powerful antenna. And it's really kind of interesting to see for, you know, $7 worth of parts, what you can actually come up with. There are a lot of things like that out there. So we will do a class on antennas. Yeah, go ahead.
I want to comment on AM radio. We often, my students used to ask me, how come most semi trucks have 2 antennas out there like that? Actually turns it into a directional signal. So more, they have more back than it does omnidirectional.
So Stan says that his students used to ask him, so if you've ever used CB radio, CB is AM radio, and you used to see this all the time, but they would put 2 antennas on their truck, one on either side mirror. And the reason for that is it turns it from an omnidirectional signal to a directional signal that's focused to the front and behind the truck. So it's focused along the road where they're driving, and that was why they wanted more power in that particular direction. So, Ragnar.
I also had a 49-foot tower that I put beams on years ago. And I think it was about $300-400, a couple of beams I did. Anyway, in West Valley, and strong winds come through there, and it destroyed both antennas over a year period. So I put an inverted V on, aimed fairly north, and I probably got more contacts on that than I did my beam. But the beam, when I had a contact, it was excellent, you know, but that's part of the challenge with it. You have to take what you can afford, and sometimes spend too much getting nothing. And so it's interesting. Antennas are always fun.
So Ragnar's comment for people on the Zoom and the recording was he had a 45-foot tower at his old house in West Valley City, and he had a couple of beam antennas on that. And one of the things to be aware of when you're doing that is wind loading, and the wind could be somewhat extreme out there, and it actually destroyed the antennas. He ended up going with a was it a end-fed half wave? An inverted V. So basically think about it as if you use the top of the tower as the apex of a triangle, and you brought a line down on either side. So it's like an upside down V. And then one of those is the driven element. One of those is the, what do they call it? The other half of the antenna, essentially the ground side of the antenna, right? And so he said he had that aimed kind of in a northerly direction, and he got a lot of great contacts on just a piece of wire, just a wire antenna. So, you know, sometimes you get what you pay for out of an antenna. Sometimes you get much more than what you pay for. But yeah, we will have a presentation on antennas, but you'll find a lot of different kinds of antennas in ham radio. These ones that we've been talking about, wire antennas, like a dipole, which is basically two pieces of wire that extend away from each other. You connect the cable in the middle, the center conductor of your cable connects to one side, and the shield connects to the other side, and that provides your connection. An end-fed antenna is basically if you take that same situation and you have, you know, one end of it with the radio connected to it, and then the inverted V that we just talked about. You'll have vertical antennas, which are like your typical mobile antenna is going to be a vertical antenna. Those are generally omnidirectional. You'll have beam antennas, which could be a Yagi or a quad type antenna or a delta. Hex beams, discones, loop antennas, which are basically a circular antenna. And you know, you might think that if I have a circular antenna, the signal is going to go through the hole and out that direction, but that's actually the null of that antenna, right? So you have to consider the directionality of that antenna as well. J-poles are fairly common. That's an antenna that basically has two verticals, one of which is shorter than the other, and the short one is actually the driven element on those. Dan, go ahead.
That the first person who says, I want it, he's giving it away, he put it right in antenna, so he took out the J-pole, and so he's a member of the club, so whoever wants it, let me know.
Okay, so Steve, I guess KG7GIT has a copper J-pole that he wants to get rid of. So if anybody wants it, let Dan know or let Steve know. And the first person who asks for it gets it. Yeah.
You mentioned earlier, your shack is in mobile, it's in the car.
Right.
And your HF?
I don't do HF.
No.
No, I'm a technician. So I haven't done any HF.
So then, next question, your antenna on your car.
Right.
Is it vertical antenna?
It's a vertical tri-band antenna, and I have a lip mount mounted on. So my vehicle is a GMC Yukon, I have a lip mount mounted on the rear hatch, and the antenna is on that. And then I run the cable from that to where the radio is underneath the back seat.
Well, a lot of questions I just don't know much. Earlier, you also mentioned that, I remember who you were talking about, maybe, Dan, down to Tooele. And he got it, I think it was 40 miles. And the signal was, simplex, or was he going through a repeater?
He's going through our club repeater.
Through here?
Yeah.
But he reached the repeater.
Yeah.
From
From way out there, yeah.
So my understanding limited is that simplex is line of sight.
Yeah, mostly. Now, different frequencies have different properties, right? And so some of them will actually follow the contours a little bit. So those signals can actually bend a little bit. I know Ragnar used to do 2-meter USB a lot, and he would be operating from up in Parley's and going around into Bountiful and up north from there, around the mountain, essentially. And so, we say it's line of sight, but sometimes it's a little wonky. It just depends on what the radio signal wants to do that day.
Well, in
So-
this case, then that's something that can go over the mountain. Yes.
It definitely was going over the mountain. He was on I-80, right? And the signal was either coming around the mountain to the repeater over here or over the edge. Yeah, over the top. I'd say most likely over the top.
And most of them are going away, but where the edge is, radio waves seem to make a band.
They'll refract a little bit from that, right? So yeah, and you probably couldn't do it with 2-meter. And definitely not with 70 centimeters. I don't know.
Well, if you're out in the woods, and there's trees everywhere. And you want to talk to somebody else that can see. You still do this. But that's,
Yeah. Now-
Just so you know, with voltage,
Yeah, the higher the frequency, the more it's going to be blocked by that, right?
2 meter is much better than 70.
Yeah. In fact, for gigahertz, like microwave stuff, they say it'll go 20 miles or through one tree, right? So, you got to consider what your signal is, what your signal looks like, right? So that's definitely something to think about. But yeah, I mean, yeah, the moisture in the foliage will cause problems. But those don't really block it very much because of the shape of the leaves and whatnot, right? So you'll find that you actually get good propagation through the woods with 2 meters. Not bad at all. I know Neil and his dad used to go out and they take their radios when they went hunting. And so they were out in various places and would communicate just fine on simplex on 2 meters over, several miles. So, it's something that when you look at like your typical GMRS radio and it says it's got 37 miles of range. Well, it has 37 miles of range if you're on top of a mountain and you're talking to somebody else who's on top of the mountain and you can see them directly, right? Then yeah, sure, you're going to get 37 miles of range. But what you're actually going to get is going to depend on what's around you and what the conditions are. So depending on the band you're using, GMRS, for example, is a UHF system. So it's not going to work as well in the woods as it does in, say, like an open area. Like we used to use GMRS when we went to Lagoon all the time. If you could give a radio, FRS, GMRS. I mean, back in those days, we didn't really. we didn't really distinguish, right? But it was probably FRS. But you could hand a radio to the kids and let them go throughout the park and be able to talk to them no matter where they were. This was before everybody had a cell phone, but that was something that we used to do. So it is kind of dependent on what the conditions are around you, and it also is dependent on the quality of your antenna, and it's dependent on the quality of your radio, and it's dependent on how much power you're using. There's a lot of variables that go into it. So sometimes you just have to get out there and experiment with it and see what you can actually get. I know when we go to the park, we do like the what's that event called, Mac, where they do the safety days or safety fair or whatever it is, safety fair at Murray Park. We usually set up a booth there and we'll wander all over the park with our radios and talk to each other and have members of the public talk on the radio to get some experience with that. And it works just fine over distances like that. And that's with trees around or with whatever, right? So it's very, very, very variable and dependent on what you're actually experiencing. Yes.
Using, like your antenna and your field itself becomes the ground plane.
Correct. Right.
So if you've got a Corvette, you have trouble.
So the comment is when you're using an antenna mounted on a vehicle, the body of the vehicle becomes part of the antenna system. It becomes the ground plane for the signal. And so if you're operating on a vehicle that is mostly plastic, and the example used was a Corvette, you may find that your signal isn't getting out as well as it would on something that's made out of steel or whatever. Yeah, do you have a comment as well?
Operated HF out of there. I used, 20 meter, 40 meter was probably the maximum because it doesn't matter. I mean, I had an antenna that would load up 160 meter, okay? But you still have to think about the other side of the antenna. And there's a lot of metal in a band, but it was only so good, right? So I could do 40 meter just fine. 20 meter was very good in the band. But you had to make sure that every door was bonded to the body. Every part of the vehicle was part of the antenna system. So as long as you go into it knowing that, you can do just very inexpensive things to improve your situation.
So Dan's comment is when he operated HF out of his van, he could operate pretty well on 40 meters and very well on 20 meters, but 80 was not very, very good. And that's because there just wasn't enough metal in the vehicle to provide a good counterpoise for that band. As far as what he was able to get out of 40 and 20, he was more successful because he used copper strapping to bond like all of the doors into the main frame of the body of the vehicle. So it was all one uniform connected electrically piece of metal. So that's something to consider as well, is that ground plane is part of the antenna system, and it's definitely something to consider. Yes, go ahead, Tony.
So a lot of you have the HP units. The big question is then what's a repeater? Club has a repeater. What kind of antenna and how does it work? Because that sounds like what we're all relying on.
Okay, so we'll talk about that for a minute. So Tony's question is, how does a repeater work? What is it about a repeater our repeater in particular, that makes it effective? So a repeater is basically two radios with some control circuitry in between them. So one radio is on one frequency and it's a receive radio, and the other radio is the transmit radio on a different frequency, right? So when you configure that in your radio, you will transmit on the frequency that the repeater is listening on, and you will receive on the frequency that the repeater is transmitting on. Okay. Now, our repeater here in Murray is located at the animal shelter. There's a big tower outside that repeater. That's what is that? About a 200-foot tower. and our antenna is at about 180 feet up in the air. And it's a gain antenna, right? Yeah, so it's a vertical antenna that gives us about 7.5 dB of gain just from the antenna itself. And then the fact that it's 180 feet up in the air also gives us additional gain. So our repeater is what, 40-watt repeater? But our effective power out of the repeater is, I want to say 320 watts or something like that. About 345 watts effective power out of the antenna. So the gain that we get from the antenna and from the location of the antenna adds significantly to the power of the repeater, right? So when we talk about depending on a repeater for communications, it matters where that repeater is. Now, around here in Utah, we have a lot of mountains. And so you'll typically see repeaters on mountaintops, and they'll often be co-located with other radio or broadcast systems. For example, television transmitters or broadcast radio transmitters. And so another factor that goes into a repeater is what they call a cavity, which is basically a set of filters. Okay. And what these filters do is they lock down the frequencies that get in and out of the radios. So the radio is connected to this cavity, and that cavity there's two parts to it. One is a low pass filter and one's a high pass filter. And so you adjust those until it's close enough together that only the frequency you want coming in off the antenna actually makes it to the radio. And then the same thing on the output side, you also have that on the transmit side, because you don't want to be adversely impacting any other radio users that might be at that site, right? So that's something that goes into a repeater setup that you wouldn't have in your handheld or in your mobile installation or even your base installation at home, is this cavity filter system. But yeah, typically those things are going to be located at a site that has a good geographical location. So on top of a mountain, Farnsworth Peak, there's a couple of repeaters there. There's one up at Snowbird. There's a couple other mountain peaks along the west side of the valley that have repeaters on them. Ensign Peak up at the north end of the valley, there's repeaters on the point of the mountain. And then down in Utah Valley, Lake Mountain has repeaters. Antelope Island's got a repeater on it. There's repeaters all over the place, right? And so ours is actually centrally located in the valley, which is awesome for us because where our repeater is, we have excellent coverage of essentially the entire Salt Lake County area. We also have some limited coverage into Utah County and Tooele County, and up to Davis County area, and even up Parleys. How far up Parleys were you able to get down?
I was from the top part.
So almost to the top of Parleys.
But
But you were able to reach the repeater; it was able to hear you. So yeah, so I mean, where our repeater is, we have a great location for our repeater, and it's a very capable system. But that's what goes into a repeater. There's all of these different components that work together to provide that. And the reason to have a repeater on top of a mountain, for example, is like we were talking about how hard it is for a signal to go through the mountain or over the mountain. But if your repeater's on top of the mountain, then if I'm over here in Murray and I'm here, I can see that repeater, and somebody is in Tooele, they can see the repeater from the other side. We can have a conversation just as though we were standing right next to each other using that repeater, which we would not otherwise be able to do on a simplex frequency, on a non-repeated frequency. Does that make sense? Ours is not. Ours is not. So there's a system called the Intermountain Intertie. That's a system of linked repeaters. And there's one at Snowbird and there's one on Farnsworth that are part of that system. The Farnsworth one covers points south, and the Snowbird one connects to points north, but those are interconnected interrepeater links. So if you think about it, a normal repeater is going to have a receiver and a transmitter. A linked repeater is going to have a receiver and a transmitter for its frequency, and then it's going to have another transceiver that's used for this link radio, which is connected to or pointed at some other repeater that also has a link radio. And so when you key up your radio, the repeater notices you and keys up. It also keys up that link radio, and all the other repeaters in the system also key up. So the intertie, I've hit it from West Yellowstone, Montana. There's one that covers West Yellowstone, Montana. Idaho has several repeaters that are on the system in Boise, Idaho Falls, and I think Pocatello areas. And then there's one at Bear Lake. There's a repeater there. There's the ones here that cover pretty much the whole Wasatch Front. There's one at Levan that covers like central Utah, continues on down into the St. George area. You can reach it from there and down into Las Vegas. And east and west, I know there's a link out into Evanston, Wyoming, and west, I don't remember. I know that there are some links that you can bring up that are not always part of the system, but they can be brought up to tie it into some California repeater systems. Arizona is also do that, right? So they can bring that link up when they want to. They don't normally leave it up all the time. I think there's a Montana link system that can do that as well. And so if you spin that whole system up, you can be sitting, in your car in Montana and talking on the radio, not using the internet or anything other than RF, and talking to somebody in Las Vegas or LA. It's really quite amazing. There's another link system in Utah called the Sinbad system that covers, you can reach it from here, but it also covers down like into Price and Castledale in that area. So kind of the southeastern part of the state. So, and I know when they do like the Races net, they bring all of these networks together. And so when you key up on that net, you're keying up over the entire state on multiple linked systems. And it's quite daunting if you think about it, that you're actually sending your signal out all over the place with a 5-watt radio that you hold in your hand, right? Pretty freaking awesome. Okay, some other antenna types that we hadn't talked about. The rubber duck, that's the typical antenna that you get with your handheld, right? Your handy talkie. They call it a rubber duck because it's a flexible antenna. Those typically aren't the best antenna, but they're good enough to get started with and to make contacts with local repeaters. You'll have variable length antennas. I've seen there's a guy, he calls himself the tech prepper. I can't remember his call sign. Gaston is his name. And he is selling an antenna that is basically a dipole, but say it's a quarter wave dipole, but you can add sections onto it to make it a 40-meter dipole or an 80-meter dipole or several different lengths. So you can adjust the antenna for the band that you want to operate on rather than depending on an antenna tuner to do that for you. There's also dish or parabolic antennas. There's NVIS, or I've heard people call it NIVIS. That's a near vertical incident skywave antenna. And the goal of this antenna is to send the signal more vertically rather than horizontally. So normally, if you think about an HF signal, it's going to go out horizontally, bounce out the ionosphere, and come down somewhere else on the planet, typically over the horizon, right? With an NVIS, you're sending the signal more vertically and it comes down much closer to you. So where a normal HF signal is going to be, 1,000 miles or something like that or more, an NVIS is going to be 100 to 300 miles or something like that. Yeah, but you can do that with an NVIS antenna quite easily, right? So there's also helical antennas, which are coiled essentially. Those I think are primarily used for space operations. And then there's the typical whip antenna, which would be your old CB radio. That's basically just a long piece of wire, right? So there's tons of different antenna types. We're going to do a presentation on antennas. We'll talk about some different antenna types, why you would choose to use them, why you might choose one antenna over another, what the capabilities are, and we'll talk about designing antennas and building antennas in another meeting. So another thing that you want to think about is mounts, masts, and towers. How do you get the antenna attached to wherever you're attaching it, right? So if you're putting an antenna on a vehicle, you need some type of a mount. The typical things you'll see are mag mounts, which is basically a magnetic thing that the antenna hooks onto, and then a cord runs from that to wherever your radio is. And you can plop that in the middle of the roof of the car, which is great because when you sell the car, you just pop that sucker right off of there and you don't have to worry about it. A through hole mount, on the other hand, you actually drill a hole through the roof of your car. My wife wasn't too hot on that idea, so I didn't go with that kind of an option. I went with a lip mount, which you can see in this top right picture. That's a lip mount, and it's basically attached on the trunk of this car. Mine's mounted on the hatch, on the edge of the hatch of my Yukon. And then you can also use some type of a bracket. I know Gordon has a bracket that he made for his truck that it bolts inside the engine compartment and then comes out through the gap, and then the antenna is attached to that. So lots of different options there. And then masts versus towers. You'll hear people talk about, well, I've got an antenna tower or I've got a mast. And some people are like, well, what in the world is the difference between a mast and a tower? So if you look at this picture, you'll see on the left is a mast, and it's a vertical structure, and it's using guy wires to support it, okay? And that's different from a tower. The structure on the right is a tower. You notice that one has 3 legs. It's self-supporting. It doesn't need guy lines or anything like that to support it. Does this one have 4? Is that a 4-legger? I can't tell. I can't tell from the picture. Dan says it's a 4-legger. But the reason you want something like this is to get your antenna up above the ground, right? Get your antenna higher up in the air. And the reason you want to do that is because you get it away from ground interference, things on the ground that would be interfering with you. But yeah, so that's the basics there. Other things that you might want are things like an antenna rotator. What this is, if you guys remember broadcast TV back in like the 70s and 80s, we used to have an antenna on the roof, and we had a little box that sat on top of the antenna with a dial on it, and you would turn that dial and the antenna would actually turn and point at wherever the transmitter was. And those antennas were Yagi antennas, so they were directional antennas, right? Well, you can do the same thing on an amateur radio antenna. You can have a rotator that allows you to direct that antenna and point it in the direction you want your signal to go, right? In this one, this picture here, this is a dual axis antenna rotator, and it's used for satellite operations. This one is set up with 2 separate antennas on it. You can see on the right is a 2-meter Yagi, and on the left is a 70-centimeter Yagi. And this, with the appropriate software, he can have this actually track the satellite automatically as it moves overhead and rises and sets as the satellite goes by. So that's kind of cool. There was a guy that came to a couple of club meetings. He never did join the club, but he came to a couple of meetings. He was building a setup like this. And if I had his contact information, if anybody has it, let me know. I would love to have him come in and bring his antenna in and show us how it works and all that. You can hand hold the antenna. If you know where the satellite is, you can follow it by hand. That's true. But a setup like this is nice because you don't have to pay attention to that. You can let it automatically track the satellite, which is kind of cool. That was telling you what way to point it. Yeah,
Pointed to change the frequency. That's at the top or.
Right.
Frequency.
right.
So you're always changing. Oh, UHF,
Yeah.
you know,
The satellite operation is kind of cool. We'll probably do a class on satellite operations. It may not be a beginner's class. We'll see what we end up with, but yeah. So what else? Grounding. Grounding is critically important for amateur radio, right? If you are putting a station in your house, you want to make sure it is grounded. Dan has a fabulous presentation on grounding. You can look at that on our club website here. He gave that presentation in 2020. Probably going to have you give it again, or at least update it and do it for one of these beginner classes. But yeah, the ground is a critical part of the antenna system, and you also want your equipment grounded because sometimes there's a lot of power running through those things, and if something gets broken or is shorts out or something like that, you want your fuses to blow quickly, so you want it tied to ground. Mac is chuckling over here because as a firefighter, he's probably seen some situations where poor grounding has caused fires, which yeah, so something to think about.
And electrical grounding and
RF grounding, right? Dan points out that grounding is probably one of the least understood aspects of amateur radio, and understanding the difference of electrical grounding and RF grounding and how that all applies to your system is right. You don't, yeah, bonding is important because you don't want to be the missing link between two pieces of equipment that are different potentials, right? You hear stories about, the guy who, whenever he keyed up his mic, he got a shock. And that was because his equipment was not grounded the way that it should have been, right? So every time he keyed up and the power hit the transmitter, the power would be, there would be a voltage potential between him and the equipment, and he would get a shock from that. So
your radio equipment, you think it's all grounded, you have all going to a ground run outside, but your equipment is plugged into your grid ground, and there's a potential.
there's a different
between
your house ground is a different place from your radio ground. Yeah. So those are all important aspects of that. And, we'll talk about that in a future date, but grounding is critical to understand and to get right, because it's very easy to get it wrong and cause yourself big problems. So how do handhelds and mobiles work when they don't have a connection to ground? Well, the radio body, and for handhelds, your body, or for a vehicle, mobile installation, the vehicle's body acts as the ground plane for the antenna. So the way those systems work on the RF side is you're the ground plane for the antenna, right? So I have seen little things you can buy that are little counterpoises that will hang off of the antenna connection. And they say, oh, this is amazing. It really gives you a huge amount of capability. But as long as you're holding the radio, you're much bigger than any of those little wires. So I don't know how much people actually get from those, but I have seen those.
Because you are not physically tied to the negative side of the antenna.
Dan points out that a lot of radios nowadays have a plastic body, and so you're not directly conducting the ground, and you're only connected inductively, right? So that is something to consider. So maybe those little wire counterpoises do work well. And then, of course, in your vehicle, we talked about how, for example, bonding the doors to the frame of the vehicle can help with making your signal get out better if you're at a particular band or whatever. All right, last couple of things, cabling and feed line. These are the parts that connect the radio to the antenna. We mostly nowadays use coaxial cable. It is not the same as cable TV cable, okay? Your cable TV cable is 75 ohm cable. Amateur radio antennas and cabling systems are all on 50 ohms. And there's a reason for that, and they'll go into the physics of that in that antenna class that we'll do later. I'm not going to go into it today. But they are different. So don't try to use, if you got a spool of old cable TV cable, don't try to use that with your amateur radio. It's not going to work the same. There's also a type of cable called ladder line. I don't see too much of that anymore. You'll see it in older installations, but I know it's still available and still used in HF. So ladder line is 450 ohm cable, and there's an example picture of it here. It's called ladder line because it looks kind of like a ladder, right? And then, of course, power wiring, you want to make sure you use an appropriate gauge of wire for the amperage and distance that you're working with. And there are charts online that you can look up that will help you pick the right gauge. One thing to keep in mind when you're talking about power, cable, and gauge, the bigger the number, the smaller the wire, okay? And the reason for that is there's actually a physical device called a gauge that is used for drawing wire. And it's like a plate with a hole drilled through it that's a particular size. And so what they will do is they'll actually put a chunk of metal on one side of it, and they'll grab it from the other side and draw it through this. And that will set a particular size of metal that comes through. And then the gauge came from how many of those you pulled your wire through. So the more gauges you pulled your wire through, the smaller the wire got. So a lot of people don't understand where that term came from, but that's where it came from. And so, typically if you're running, 30 amps over a longer distance, you're going to want to use a 4 gauge or something like that, or 8 gauge wire. If you're doing something with like 10 amps over a shorter distance, you might get by with a 16 gauge wire or something like that. But you'll want to figure that out, identify your application. How long is my wire? How much power am I putting through it? And figure out what gauge you want. You don't want to have your cable be too big, because then you're wasting energy putting it through that cable. Okay, you want it to be sized exactly right for the application that you're working on. Okay, and this is the last thing, connectors. So we have different kinds of connectors that are used for coax. You'll see, let me pull up the laser beam again here. So here you've got, this is an SO239. SO stands for socket. And I don't know why the number is different, but the connector that goes on that is a PL or plug 259. I don't know why one's 239 and one's 259. There's some obscure reason back in the military where they came up with these numbers, why they were different. But that's the PL 259 goes onto the SO 239 connector. These ones are BNC connectors. And one thing you'll notice if you look at BNC connectors at like Lowe's or Home Depot, if you see this white ring in here, if it has that ring, then that's a 50 ohm connector. If it does not have that white ring there, then it's a 75 ohm connector for cable TV. Don't use it. Okay, so that's something to look at and consider. And then, of course, there's male and female versions of these. These are great because they're a bayonet style connector. They're very robust. You can connect and disconnect them multiple times over the lifetime, and they'll do just fine. There's also type N connectors, which are these are weatherproof connectors. They're very good for antenna connections outdoors. They're really good connectors. For power, we've typically standardized on what they call Anderson power poles, and these are power connectors. They're available in different amperages, so there'll be different sizes for the different amperage. The 15 amp version will be smaller than, say, the 30 or the 45 amp version. You want to size your connector for your application as well as your wiring, right? The advantage of these is when you put it together correctly, you cannot plug these in wrong. So that's a very nice feature of this type of connector. And then some kind of power distribution. And I've got an example here. This is a box that has Anderson power pole connectors on it. So these connectors will plug in to this box. And then it's also got fuses built into the box. And so it's very easy to plug in multiple pieces of equipment into your power. So you would feed your power in through one connector and then out to your different radios through those different connectors. So that is all that I have. And it's right around 8 o'clock. So good timing. Questions?
Well, I learned the trouble over the years, but he, what he, this one, and I have fun.
Oh, I think the B is for bayonet. Oh, a British Naval Connector is what the BNC stands for. That's interesting. I did not know that. British Thermal Unit. Yeah, BTU for British Thermal Unit. Interesting. Interesting. I was not aware of that. I always thought the B stood for bayonet because it's a bayonet type connector. Other questions, comments? Anything from online? Nope. All right. I'm going to stop the recording.